In this video, we will explain how to carry out an assessment of the proper functioning of an air conditioning system using exclusively temperature values. Let's begin by highlighting that the average temperature in the pipes of the evaporator or indoor unit of a properly functioning air conditioner should be around 5 degrees Celsius. On the other hand, the average temperature of the condenser in proper operation, located in the outdoor unit, should be approximately 10 degrees Celsius, higher than the external ambient temperature. Now, let's analyze that when an air conditioner is turned on, a supply air flow is generated initially at ambient temperature. As it passes rapidly through the evaporator, which is at 5 degrees Celsius, it cools down and reaches about 10 degrees Celsius. Let's assume that after a few minutes with the equipment on, the temperature in the room is approximately 23 degrees Celsius. Now, part of the air in the room at 23 degrees Celsius is drawn in by the evaporator fan at 5 degrees Celsius, returns to the indoor unit, where it is cooled again to reach 10 degrees Celsius, and is then returned to the room, to repeat the cycle. When analyzing a properly functioning split system, it is important to note that the thin pipe is the path through which the refrigerant enters the evaporator unit, and in this pipe, the refrigerant is in a liquid phase, while the thicker pipe is the one the refrigerant uses to return to the outdoor unit from the evaporator, and it is in this pipe that the refrigerant is in a gaseous phase. When a system is in operation, as mentioned earlier, two different temperatures should be present in the thin and thick pipes. For example, the thinner pipe that introduces the refrigerant to the evaporator should be close to 5 degrees Celsius, while the thicker pipe that extracts the refrigerant from the evaporator should have a higher temperature value, for instance, around 9 degrees Celsius, as the refrigerant absorbs heat from the room air, thereby gaining some temperature. With these temperature values, we are talking about a refrigerant superheat of 4 degrees Celsius. In the event that these two temperatures are close, it indicates that heat from the air is not being received, so we should focus on A. Possible issues such as dirty air filters or evaporator freezing, which hinder the passage of air through the indoor unit or evaporator. B. A slow turbine speed that reduces the airflow through the evaporator. On the other hand, when the superheat is very high, for example, the thinner pipe is close to 5 degrees Celsius, while the thicker pipe has a temperature value of, for example, 15 degrees Celsius, suspect refrigerant deficiency. If, with the compressor running, the thin pipe never cools, we should suspect a lack of refrigerant, a clogged capillary tube, or even a mechanically defective compressor.